Okay, constraint satisfaction kind of a thing. Okay, very simple. For example, we talk about some game kind of a. So suppose this one is the Sudoku. I made some tables. So I am considering the first portion, and we know in the Sudoku first portion, the things are this you should not, but if there is a 1, then this column there should not, repeat somehow the 1, or maybe here 2, 3, then 4, 5, 6, 7, 8, 9. Are you getting my point? Yes, no element is repeating itself. In any row or any column diagonally whatsoever. There is the satisfaction, constraint satisfaction, condition satisfaction, that element or the integer should not row, in a situation. Even here, this is a complete column, and this complete column, you should not repeat again here 7. Are you getting my point? Yes. This is the satisfaction kind of stuff. Okay, this approach basically is somehow heuristic approach. Constraints mean that conditions. That in this whole, there are the 3 here, 3 here. So these elements should not be repeated in the same column or the same row. So this helps out in decision methods. Or you can say if we are violating the constraints, then for example on the red light, the cars are, then accident will happen. If the car will move on a red light, then accident can be happen. So this is the violation of the constraint, violation of the condition. Then on the green you can move, on the red you should stop. This is the situation. Your AI system, the self-driving cars with many other things, they follow the similar situation. In a moment ago, there is a chess. There is also some kind of a game. You can say that end queen game. If I say that in this 4 by 4 matrix, and this is the extra line, so 4 by 4, and in this here the diagonal same element, queen should not be here, the diagonal only once, vertical only once, horizontal only once, in each row only once. Constraint condition, like you are playing the tic-tac-toe game, so if you want to win, so like this. Similarly, for example, you are observing the map coloring. Map coloring. This is the American spelling of coloring. Don't worry. So, map coloring. For example, if you are making some kind of a map of Pakistan. So, if this one, you can say that the area. Kashmir, whatsoever. There, Indian territory like thing, just after this is a border. So each, if you are giving the red color to it, then the Azad Kashmir should have the blue color. The river should have the green, like this. But you cannot give the adjacent color to the nearby area. One color to each particular area.
No repetition.
No repetition. If we see such kind of thing, then we can analyze the cryptic arithmetic, or you can say that n queen problem. Note down, I may ask simple questions related to it. You need to study all these. Crossword problem. color problem, color
Problem.
Latin, LAT, Latin scale.
Problem.
So there are many problems like the Sudoku. Okay, you need to note. Is it clear, please? So,
Yes, sir. Sir, excellent, sir.
yes. Whatever these, actually the theme of all this, we want to get the distinguished feature, we want to make some decision or the discrimination or the recognition of a stuff. For example, if I am talking about some face and the face, okay, so suppose there are the four expressions of the similar person. In the first situation, you can say
Emoji.
yeah, happy.
Yes, sir.
Okay. The second, sad. Okay, I'm sorry.
Oh, sorry.
Crying.
Yes. Yeah.
Crying one.
Happy.
Now, happy.
So much happy, sir.
Happy. Too much happy. Overflowing.
Thank you.
Okay.
In pain. Pain, sir.
Okay.
What's the pain?
Same, sir.
No, not same. Just check out. Okay, eyes check out. Okay.
No, it's not.
Naughty. Okay, now see, if you want to recognize the object detection of the face, the big feature, there are three possible things. With big, simple face, big feature is what? Basically face, whole complete face. Big feature, face. If I am talking about
Small.
small feature,
Eyes and
Eyes, nose,
yes,
eyes and
lips.
small features mean eyes,
and lips.
lips,
Nose.
nose, mouth.
Cheek.
Okay, that's fine.
Small.
I agree. Okay, but even with the big feature, you cannot recognize it properly. Even with the small feature,
You can.
no, you cannot recognize.
Little bit.
My children, see, there are the eyes, there are the nose, there are the mouth. You cannot recognize. Even in this face, okay, you cannot recognize. But the important thing, if you are considering the somehow intermediate feature, if you look into the intermediate feature, then somehow you can please explain. I understand you are good, but for getting the result, okay, intermediate feature, you can say that combinations. Intermediate feature, then you will say combination, the combination of eyes and nose and the lips. Okay, then combination. All three features should be. If you say the eyes, this eyes, okay, you can say somehow. So small feature does not help out a lot. So intermediate feature combination.
Both small and big.
No, combination means
Combination of small features.
combination of small features. Yes, combination of
Small features.
small feature as well as the big feature. Okay, face.
Okay.
Yeah, you should not make some eyes in the pumpkin. Okay, so is it okay?
Okay,
But
sir.
problem is this: we need to actually. These are the sometimes sentiment analysis, sometimes other situations. How we can measure. If I am talking the some standard, okay, you can say passport size photo. That is some standard picture.
Yes, sir.
Resize the picture, sir.
Of course, in 2D, this x-axis, y-axis. Please, I need your kind attention. So, suppose the standard, this one is the standard picture. Somehow, okay, picture somehow. But if little bit, okay, small moment of happiness give you a smile, so you can say that this one is somehow, you can say that the A represents the first, this one. A represents the first one. And this, of course, okay, with respect to, this one is the standard, then angle will be changed of the feature expression. Then this one, angle theta A. Then the next one, B, then here it will theta B. Theta B start from here, okay? From the standard. And then you may say the third one, angry. Okay, so C. And this one you may say theta C. But my children, this one somehow in a pain or somehow in a naughtiness, okay, we do not actually, this is somehow unpredictable or unknown to us.
Yes, sir.
And this unknown to us, basically we want to determine, we want to recognize it. The face belongs to the person, okay, we want to label it. Then in this situation, you can say that it is out of the range, somehow its angle is too much. So this one, and in this
So this is
situation,
which one, sir?
D.
Unknown one.
Unknown.
this one, okay,
D.
this one for unknown here. So now, okay. So in situation, because the expression are very, okay, in the naughtiness phase, you can say you cannot notice it clearly. So here unknown, and the angle here, of course, theta u whatsoever like this. My children, this is somehow geometrical expressions. And of course, if I'm talking about the x-axis feature related, okay, this one, then you can, if you are considering this with respect to some standard, okay, as, okay, you can say cos theta A minus, okay, vertical, change along the, okay, height somehow, minus ys sine theta A. Similarly, here x b, or you can say xs cos theta b minus ys sine theta b. So x c, you can say xs cos theta c minus ys sine theta c.
Sir, can you
Yes, please.
Sir, how
sir,
they are?
kindly explain the equation?
Yes, this one is the basically movement, okay? Of course, if I'm changing the angle or whatsoever or phase, the basically my legs are there, but these are changing their geometry.
Sir, what's about
Geometry-
unknown?
Huh?
Unknown.
Unknown.
X.
Yes, unknown. Unknown, my children. Unknown, of course. Unknown. Okay, sorry. Unknown will, of course, will be the sum of all the, okay, fusion of all the features. So you should have the weight values, theta A, x A plus theta B, x B plus theta C, x C. You need to sum up. Somehow, this is the, okay,
Sir, these x's and cos, you kindly explain these.
this one x
These
A,
are all
x B.
different.
Basically, I told you many times the x are representing some kind of features. But features here are geometrically, okay, somehow changed in terms of, okay, along the x-axis or y-axis. Basically, what are I am speaking? Here, please, I need your kind attention. I say, what is your nice name? I say, Anik, this is my first expression, 1D audio signal. This is somehow kind of a wave, okay, propagation. And the ones you are having the wave propagation, geometric expression are there or not?
Yes, sir.
There. This is 1D signal. Then I say, Anik, this is another expression. What happened? So this is somehow, this is expression. So signal change. So we similarly once we are dealing the image is what? 2D signal. This one is the 1D representation. This is the 2D representation. In a similar case, okay, situation, your features are okay somehow changed in each expression. This your each expression, my child, your features are okay like your wave, sound wave, 1D signal. They are behaving different. So we are considering this.
So X is one dimension and Y is the other one.
Yes, of course, it's the x-axis in the two-dimensional geometry, x with respect to standard and y with respect to standard. And this is the first x, okay, feature. These are the
So
things.
X for Y we sum up them.
Yeah, please, sorry.
X is the angle now.
X for not.
X unknown.
If my English is not good, then why you are highlighting here? I'm sorry. Thanks for correction. X unknown.
Yes, sir.
Unknown.
Yeah, sir, why you sum up? Sir.
Why we sum?
Yeah, sum up. Let me explain to you people. Basically, we want to increase the data, and once we are having these weight, okay, somehow the strength of the weight will be increased with respect to each feature, okay? So the feature will add up with respect to weight, and the weight will show some particular inclination that this phase expression belongs to the Hussain or to the Numan. Are you getting my point? So even you are in a naughtiness, okay, but it will be observed, okay, that this will be unknown, can be, okay. Is it okay, please? Not 4. Okay, I'm sorry. Okay, thank you. Okay, but sometimes, if you allow me to speak.
X1 to X4.
Okay, for a Nico only, okay? Let me explain. For example, the similar phase, if I am expressing this phase, okay, this one, if I do like this,
तुमने क्या लिखा है यहाँ पे? कितने?
okay, this is suppose somehow,
One direction.
yeah, 1D signal, okay, but if I spoke out a little bit loud, what happened? Yeah, this signal are
Amplitude change. Amplitude.
amplitude are, okay, just suppose I spoke it with some delay, okay, or you are in the communication, you are getting the signal with some delay sound, so it may be possible that you will have this at this position. So, okay, so my children, now it is not at this original, okay, this is the origin.
Yes, sir.
It is moved far away, and once you are getting on the mobile phone some sound with some delay, maybe there is some noise in it. Noise in it with the original signal.
Distortion.
So distortion. Okay, in the situation like this, what you want to enhance or you want to maximize the original signal in this situation. Similarly, here in this case, we want to maximize the Numan summation y summation. Let me explain the summation concept. We want to maximize the features. Okay, similarly, we want to maximize the signal, okay, but in the 1D signal, of course, if I say 1D signal, then it's very easy, f of x, okay, so you can say, then, sorry, another signal, the shifted, translated signal. Translated signal one, so g, x minus big X, okay, feature kind of thing. So, like dx. Big X represents some feature and along the x-axis is moved. So, summation basically sum up, okay, this sum up, okay, this is the translated, okay, the second, okay, signal somehow translated one, this is the original, this one, and those, this is some kind of a combination, and, okay, you are, this integral, you studied in the calculus, okay, did I teach you calculus?
No, sir.
What's the theme of integral?
Combining things.
Combining, technically, this word S is a French mathematician, okay, you can say French people write the sum, okay, very badly, and they write some like this, and this basically S, integrals show what? S, and it means that sum. What is show? Sum, okay, so we are maximizing it, summing up, my child, here we are summation, summing up, okay, we are maximizing its okay, feature like this. So if you are talking about this is the 1D signal, if I am talking about the 2D signal, then it will act like max, x, y. So here you will see like this, okay, this function, 2D function, okay, 2D, okay, then it will be shifted like this, x minus x, y minus y, then you can say dx, dy, this small increment, this dx represent, my children, please, I need your kind attention. So dx, okay, let me here speak out, this one, small movement, okay, small movement along the x-axis. If there is a dx and dy, small movement along the x-axis, small movement along the y-axis. So sum up all the movements, sum up all the changes, and you will get the net, okay, expression of the phase, and you will recognize the summation. Just please.
Sir, and this capital X and capital Y represent the feature?
Yeah, basically changing the feature. Okay, change the feature. For example, you need to cover 100 kilometers, but you cannot make it 100. So some less. Okay.
5 or 10.
Yeah, whatsoever. So difference. Okay, some values. Are you getting the point?
Yes, sir.
Yes.
Yes, sir.
I do not need to teach you. Such a genius as Sam today may. Okay, rock the.
Yeah, yeah.